Hello and welcome to the asynchronous portion of chapter 6. In this topic, we are just going to learn what is electrolytic cell and how can we apply this in our home lab activity. Just a reminder, this is not included in your upcoming quiz next week. So hindi siya kasama sa quiz. Instead, this will just be useful in your home lab activity. Okay? So, hanggang Nernst equation lang tayo sa quiz. But for the home lab activity, electrolytic cell yan. Okay? So first, let us give the concept or context on what electrolytic cell is. Okay? But before that, let us recall that there are two types of electrochemical cell. Okay? So there are two types of electrochemical cell. One is voltaic and the other is electrolytic. We know that voltaic cells spontaneously produce electricity, meaning that these cells have a potential value of positive numbers. No? So positive yung kanilang mga potential. While for electrolytic cell, their potential is negative, meaning that the reaction is not spontaneous. That means you have to add electricity for a non-spontaneous reaction to happen. Okay. So there are many applications of electrolytic cell. One of it is a down cell, which is used in the production of sodium and magnesium metal, as well as chlorine gas. So these metals and chlorine gas are used in industries to create many types of products and even in sanitation. So ginagamit sila. So for example, we have here the illustration of how a down cell look like. So basically, you have the solution of molten sodium chloride, and when you add electricity to it, the sodium chloride turns into chlorine gas and sodium metal. Okay. So again, maraming purpose yan. Maraming uses yung chlorine gas and the sodium metal. Okay. The other example of electrolytic cell is the electrolysis of water. So this is used in spacecraft, just as I mentioned to you in our lecture and laboratory discussions in the past few weeks. So I mentioned there that astronauts in the International Space Station were able to breathe in oxygen because of the help of electrolysis. So in the International Space Station, they have this electrolysis device, which I will show you. Okay. So in the ISS or International Space Station, they have this electrolysis device, which is powered by the solar panel of your spacecraft. And this device provides them oxygen that they can breathe. No? Kasi you might be thinking that the oxygen they breathe comes from Earth. No? But in reality, that's not. It's too expensive to bring air from Earth to the ISS. So they have this own device wherein the liquids they produce, for example, in their purified urine, they will be electrolyzed so that it will produce oxygen gas. Okay. So this is how the experimental setup will look like. So you have here an inverted test tube, and then you have two electrodes here. And in these two electrodes, uh, there are different types of gases that are produced. For example, in your anode, the water is being electrolyzed to produce oxygen gas, 4 moles of hydronium ion, and 4 moles of electron. So kumbaga, this is the oxidation version in an electrolytic cell. Meanwhile, in your cathode compartment, you have hydronium ions. Okay, sorry, this is not balanced. So you have 2 moles of hydronium ions accepting 2 moles of electron that will give off 1 mole of hydrogen gas. Okay, so there you go. Balance na pala siya. Okay, so in one compartment, let's say this is our cathode, it will produce the hydrogen gas, and in the anode, it will produce the oxygen gas. Take note of the volumes of hydrogen and oxygen gas that, as you can see, the volume of hydrogen gas is twice as many as the volume of oxygen gas. Why is that? That is because of the stoichiometry. According to this equation, the overall equation for the electrolysis of water, when you electrolyze 2 moles of water, it will produce 2 moles of hydrogen gas and only 1 mole of oxygen gas. It means you will get twice as many hydrogen gas than the oxygen gas. And this is what we're going to replicate in the experiment. Okay, we will try our best using our home materials to recreate electrolysis of water, and and that will allow us to solve for the Faraday's constant experimentally. So in order for us to do necessary calculations, there are some quantitative aspects that we have to understand that is involved in electrolysis processes. So first, when you apply electric current to your solution, there is certain amount of charge that passes through it, and that can be calculated as the product of the current and the time. Okay? Kasi di ba kukuryentehin mo yung water. So for you to know how much electricity passes through the water, you have to multiply the electrical current, which is in amperes, and the time at which the electrolysis takes place. The time here is in seconds, so meaning if you have minutes, you have to convert it into seconds. So by multiplying this, we will get the overall charge Q, and this Q is actually coulombs. Okay, so its unit is coulombs. On the other hand, we can express the total charge as the moles of electrons times the Faraday's constant. This is another equation known in physics, and that means since they are both equal to the charge, no? So the IT and the NEF are both equal to the charge, meaning we can combine them to form this entire equation IT equals NEF. Okay? And this is the equation we are going to use in order to determine the Faraday's constant experimentally. Okay, so these two are equations known in physics, and we are going to use them in order to get the Faraday's constant. Again, let us recall that the I is your current, which is in amperes. T is the time in seconds. N is the mole of electrons. And F is the Faraday's constant. Later, I will show you how you will interpret the results of your experiment using this equation. But for now, let's look into how are you going to proceed with your experiment. So for your home lab activity, you have the following materials needed. So I'll just play this short clip. You have to have a 9-volt battery, 2 pencils, sharpener, alligator clips, some iodized salt. You can have either graduated cylinder or beakers, or if you have test tubes, you can do that as well. And finally, you can have tub, okay? And of course, water. Okay, let me pause here. So, just as I mentioned, if you don't have test tubes right now, it's okay if you use graduated cylinders or beakers, okay? So as long as it can hold the gases, you can use them, okay? But for the experiment, I used graduated cylinders because it produces, sorry, it is already calibrated. So I can easily determine the volume of gas that will be trapped in this, okay? But again, you can still use test tube or beakers. For the tub, you can look for alternative of this. For example, Tupperware with a considerable height, okay? You can also use Tabo or Dipper. You can use that, okay? But in my case, I have this spare tub from the kitchen, so I use, okay? So those are the only materials. Again, just to emphasize, the battery here should be 9 volts. Okay, so for you to do the experiment, you have to sharpen both ends of your pencil. That means you have to remove this metal part on top with the eraser. So kindly remove that and then proceed on sharpening your pencils. Okay. So I'll skip this portion. Make sure that they are properly sharpened at both ends. So it took me a while to sharpen them. Okay. Again, make sure that the sharpened pens should have a considerable length of your carbon graphite there. Okay. The pencils will serve as your electrodes in the electrolysis setup. Next is for you to set up your electrolysis chamber. So in order to do this, you just add water to your tub or beaker or Tupperware. Okay. Fill it halfway. So just fill it halfway, and then you have the gas collection vessels. You can use either beaker, um, graduated cylinder, or test tube. But in my case, I use graduated cylinder. So you have to fill the graduated cylinder with water. Make sure that no air will be trapped inside it, just like that. And then you have to invert it. Okay. Again, you have to make sure that when you invert it, there are no gas particles trapped inside your graduated cylinder or test tube. Okay, so it's up to you kung ano gagamitin niya. Okay, so just fill it with water, ensure that there's no air bubbles trapped inside, and you have to invert it like that. Next thing is for you to add salt. Okay, sorry. So there I added some amount of salt. Um, I wasn't able to count how much salt I added, but I just added a considerable amount. The purpose of salt is to make the solution conductive, okay? Because without salt, the conductivity of water is very low. So just add at least 1 tablespoon, although I was unable to measure how much salt was there. Okay, and then using your inverted test tubes or graduated cylinder, swirl the solution until the salt is fully dissolved. Then after that, using your 2 pencils, submerge the ends of it, making sure that um, their ends will reach the opening of your graduated cylinder. So just observe what I did in the video. So I positioned the pencils in such way that their ends are pointing towards the mouth of your graduated cylinder or test tube. You can secure them in place using scotch tape. So gamit lang kayo scotch tape because that will help things to be stabilized. Okay. So this is the final setup. Let me pause it. So again, your pencils will serve as the electrode. One of it will be the cathode, one of it will be the anode. This is your water with salt, and these are your test tubes that are inverted. And make sure that there's no bubbles here. Okay? So double check na walang bubbles done. And again, you have to ensure that the tip of the pencil is pointing inside your it's pointing inside your graduated cylinder or test tube. Okay. Now, once you set up everything, as you can see, I added more scotch tape so that the electrodes will be secure. Once you set up everything, you can now connect them with an alligator clip. Okay. So you need two alligator clips, connect them in the carbon rod, just like that. And then connect the two alligator clips to your battery and make sure that you have your timer with you. This experiment should last for around 45 minutes. Okay. So once you connected these electrodes to your battery, make sure to start your timer. Again, you have to double check if the position of your electrodes and graduated cylinder are perfect. Make sure also that your alligator clips are well clamped to your carbon rod so that the electrons from the battery can pass through the wire to the carbon and then into the solution. So you have to run it for 45 minutes or 2,700 seconds, as I mentioned. And as you can see, in one compartment, you will have a lot of bubbles of gas. Okay. So for example, in this compartment, I have so many bubbles of gas, while on the other one, I don't have that much. The compartment with the most amount of gas bubble is actually your hydrogen compartment. So this is your reduction or the cathode compartment. This is where your hydronium ions get converted into hydrogen gas. Okay, so this is your cathode. Again, run it for 45 minutes. Then after 45 minutes, stop timer and disconnect your battery. And you have to record the volume of the gas produced in the hydrogen compartment only. Okay, so again, only the volume in the hydrogen compartment should be recorded. How will you know if that is the hydrogen compartment? Well, it contains most of the gases. Okay, so it contains most of the gases. The other compartment, which is oxygen, it doesn't hold that much gas. Well, that's because of experimental setup. Okay? There are some errors in the experimental setup, but yeah. So just measure the volume of gas here in the cathode compartment. So disconnect the battery and make sure that the air bubbles go upwards to your test tubes so you can shake them. As you can see, all those gases are hydrogen gas. Okay? While here, you have some amount of oxygen gas. Okay? There you have your oxygen gas. So I tap the graduated cylinder so that the air bubbles down at the bottom of the graduated cylinder will go up by buoyancy. Okay. So I tap it, and then make sure that you record the compartment with the most amount of gas. This is your hydrogen compartment. You can record the volume by placing a mark with your pentel pen. If you're using test tube, you have to mark it with pentel pen and then use your graduated cylinder to measure how much volume is in there. You can use graduated cylinder or syringe. So it's up to you, whichever is available at your home. Okay. So to interpret the data, as I mentioned, one compartment is the cathode wherein hydronium ions are being converted into hydrogen gas, and the other compartment is the anode wherein water is oxidized to produce oxygen gas. Okay. Well, so these are some of the data I need to collect. So I determine the time using a stop clock. So I have 45 minutes of runtime, and the volume of hydrogen gas I produce is 5 ml only. The atmospheric pressure in my area is 1011 hectopascal. How will you determine this? So just go to the Windy website. So here in the Windy website, you can look for your location. For example, I'm in Valenzuela. So I'm going to click Valenzuela. So upon choosing your place, you have to go down here. You have several options here. You have the basic, waves, wind, and the meteorological data. So you have to select this, and as you can see here in the pressure, you have hectopascals, and these are your pressure. You have to take note of the time you did the experiment. So I did this around 12 midnight, and the air pressure by that time was 1011 hectopascals. If you don't have thermometer with you, you can use the temperature given in this website as well. So by the time I did the experiment, it was 27 degrees Celsius as well. Okay. So again, the temperature and the pressure can be obtained from Windy. So just go to Windy and look for your area. For example, I'm in QC. So if I am in QC, then the temperature is 26 and the pressure is still 1011 hectopascal. Okay. So these two data can be obtained from the Windy website. And then for the current, I measured this um, using a multimeter, and I read around 0.015 amperes. This is fixed for all the experiments that we will do. So I suggest you also use this current. Okay. So please use this current as well. This will be our constant current throughout the experiment. Okay. Now, let's try to solve for the moles of electron. How would you solve for the moles of electron? Remember, I have some amount of hydrogen gas, which is 5 ml. Then using stoichiometry, I can convert 5 ml of hydrogen gas into the moles of electron. But first, how will you convert 5 ml of hydrogen gas to moles of hydrogen gas? Well, you have to use gas laws. So let's use ideal gas equation. So that's PV equals nRT, wherein the N here will be the mole of hydrogen gas. So to solve for the mole of hydrogen gas, we can cross multiply the pressure and the volume and the R and the T, giving us PV over RT. For the pressure, I obtained it using the Windy website. Okay. And the volume, I measured it using my graduated cylinder. Okay, so this is the volume collected in the cathode compartment, the one with the most amount of air bubbles. R is the gas constant and T is the temperature. So let's try to solve for the mole of hydrogen gas using the experimental data I have. So for the pressure, I have 101 hectopascal. Now, how will you convert it into atmospheres? So 1 hectopascal is equal to 100 pascal, and 101,325 pascals is equal to 1 atm. So we have to do several conversions to convert hectopascal into pascal, then into atm. So I will show it here. So I have 101, 1 hectopascal, and I'll convert it into pascal, and I will convert it then to atm. Okay, so that's our conversion for the atmospheric pressure. Now for the volume, I can simply use the volume of the gas measured using graduated cylinder. So I have 5 ml. I have to convert this into liters. So uh, we have 1000 ml in 1 liter. For the R, this is just the gas constant, so 0.08206 liter atmosphere per mole Kelvin. Then for the temperature, I also determined it using Windy website, and it stated that the temperature in my area is 27 degrees Celsius. But I have to convert this into Kelvin, so I will add 273.15. Now to get the mole of hydrogen gas, you can just simply calculate for it. So let me use my calculator to solve for the mole of hydrogen gas. So we have the hectopascal converted into atm, then the volume converted into liters, gas constant, and then the temperature, which will be converted as well into Kelvin. So this is now the mole of hydrogen gas. Okay, so 5 moles of hydrogen gas is equivalent to 2.03 times 10 raised to negative 4 moles of hydrogen gas. So I guess I will copy up to the 4th decimal place. Okay, so 2.05, sorry, 2.0255. Okay, so this is now the mole of the hydrogen gas. But remember, in our equation for solving the Faraday's constant, we need the mole of the electron, not the mole of the hydrogen gas, right? So we need to convert the mole of hydrogen gas into the mole of electron. And in order for us to do that, we can do stoichiometry. So let's say we are solving for the mole of electrons, and we are given the mole of the hydrogen gas. Using the equation, we can convert the moles of hydrogen gas into mole of electron. Remember, we have 1 mole of hydrogen gas per 2 moles of electron. So that means this mole of hydrogen gas needs to be multiplied by 2 so that we will have the mole of electron. So let's solve for this times 2. So it's 4.0510. Now, this is the mole of electron that we need to use so we can solve for the Faraday's constant. Okay. So again, just to summarize everything, once you get the mole of the hydrogen gas, you have to convert it into mole of electron. How? First, you have to get the moles of the hydrogen gas using the ideal gas equation. The pressure and the temperature can be obtained from the Windy website. So just go to this meteogram and then it will give you the pressure and the temperature at a specific time. And of course, please look for your area because at different areas in the country or in the world, there's different pressure and temperature as well. And they can affect the results of your experiment. Don't forget the conversion factor of hectopascal to atm and the ml to liters and Celsius to Kelvin. And once you get the moles of the hydrogen gas, you have to convert it into moles of electron because remember in our equation earlier, okay, so if you can still recall, the equation is IT equals NEF. Okay, so the charge is equals to current times the time. It is also equal to the mole of electron times the Faraday's constant. This is the mole of the electrons that we are pertaining to. Okay. Now we can proceed with the calculation for the Faraday's constant. So to solve for the Faraday's constant, that's pretty straightforward. So that will be IT over NE. So remember the current, as I mentioned, it is fixed. So in your calculation, please note that the current is 0.015 amperes. Okay, so it's 0.015 amperes. And then for the time, it's in seconds. So 45 minutes is 2,700 seconds. Okay, so 45 minutes, you have 1 minute, 60 seconds here. So this will give you 2,700 seconds. Okay. And then you have to divide it by the moles of electron. So the moles of electron I obtained from the previous calculation is 4.051 times 10 raised to negative 4 moles. Now I can solve for the Faraday's constant. Okay, so it will be 0.015 times 45 times 60 divided by 4.0510 times 10 raised to negative 4. And this is the Faraday's constant I obtained using the experiment. So it's 99975.31. When you multiply ampere and second, it will give you coulombs per mole. Okay? So ampere times second is coulombs per mole. Or the other version of this will be joule per mole volts. Or the other version of it will be ampere second over mole. All of them are equivalent. Okay, so they are all equivalent. And then eventually you will be asked about the percent error. So to get the percent error is just true value minus experimental value You have to get their absolute value over true value times 100. So remember, the true value of our Faraday's constant is, it's 96485, right? And our experimental value here is 9,900, sorry, 99,975. Okay, so let us solve for the percent error of our experiment. So we need to get the absolute value. So where is it in the calculator? So this is the absolute value. So the true value is 96485 coulombs per mole. The experimental value I got was 99975.31, and that will be divided by the true value 96485 times 100%. So I have a percent error of 3.62, which is actually acceptable. Okay. Okay. So you have to do the experiment twice. That's why you have two different batteries. You cannot reuse the battery once you used it. Okay, because remember, the charge of the battery might have decreased and it might affect the current that will pass through your electrodes. So again, you have to use two different batteries and you have to run this experiment twice. Well, the experiment is actually not that hard, but you just have to wait for a while, 45 minutes, until you can get your results. Okay, so I will post this video on our canvas, so please watch it, and then if you have questions you can ask your instructor. Again, this is not included anymore in the exam and even in the quiz. Rather, you just need its concept so that you can work on with the problem in your laboratory. Okay, so thank you for listening, and I hope you learned something. Let me know if you have questions. Okay, so thank you and bye-bye.